All right, welcome to our SPM Chemistry Masterclass. Today, we're going to absolutely conquer a huge topic, neutralization. We'll break down the concepts, nail the calculations, and even look at the common traps that catch people out. By the end of this, you'll be walking into your exam feeling totally prepared. Let's get right into it.
Okay, before we dive deep, let's get you set up for success. The best way to learn is by doing, right? So you can find a ton of past year questions over at www.mcqspm.com, or you can just grab the MCQ SPM app from the Google Play Store. Go ahead, scan this QR code now so you're ready to test your skills right after we're done here.
So, here's our game plan for today. We'll start with your study toolkit, then really dig into what neutralization is all about. After that, we'll see where it pops up in everyday life, then tackle those all-important exam calculations. And we'll finish up by showing you the top exam traps so you don't fall for them. Let's go!
First things first, you can't solve the problems if you don't get the basics. So, let's ask, what is neutralization really? Once you get this core concept, I promise everything else just clicks into place.
Okay. Here's the textbook definition you absolutely have to know. Neutralization is a reaction between an acid and an alkali, which you might also know as a base. And what does it produce? Just two things, salt and water. That's it. It's like a perfect chemical balancing act. So that's what happens, but what's the real story here? What's going on at the molecular level that makes this whole thing work? What's the secret sauce? Well, the secret starts with the acid. The star player, the little particle that gives an acid its acidic punch, is the hydrogen ion, the H+. Think of these guys as tiny little packets of energy, just itching to react with something. And on the other team, from the alkali, we have the hydroxide ion, or OH-. This is the perfect partner for H+. You can't have one without the other in this reaction. They're basically made for each other. And this right here, this is the main event. This simple ionic equation is the true heart of every single neutralization reaction. You take one H+ ion from the acid, you combine it with one OH- ion from the alkali, and what do you get? A neutral water molecule, H2O. All those other ions, like the K+ and NO3- you see here, they're just watching from the sidelines. We call them spectator ions for a reason. Okay, this isn't just some abstract concept for the lab. Why does this matter? Because neutralization is happening all around you every single day in ways you probably don't even think about. Let's check out a few examples, and hey, these also happen to be classic exam questions. Now, this is a super common exam question, so listen up. Ever been stung by a bee? That venom is acidic. So what do? You neutralize it. You use a weak alkali, like baking soda, to calm the sting. But a wasp sting is the opposite, it's alkaline. So to treat that, you'd use a weak acid, like vinegar. It's simple neutralization, saving the day. And it goes way beyond that. Every time you brush your teeth, your basic toothpaste is neutralizing the acid produced by bacteria in your mouth. Get heartburn? That antacid you take, like milk of magnesia, is just an alkali neutralizing that extra stomach acid. Even in farming, they use an alkali called slaked lime to neutralize acidic soil so crops can grow better. See? It's literally everywhere. All right, let's switch gears and get into the section that can really make or break your exam score, the calculations. We're going to focus on one powerful formula that is your key to solving pretty much any titration problem they throw at you. Have a look at this. This is a real question from a past year paper. It gives you some volumes, one concentration, and asks for the missing one. Now, it might look a little intimidating at first glance, but once you have the right tool, it's actually pretty straightforward. And here is that tool. This is your secret weapon for titration. M stands for molarity, that's just concentration, and V is for volume. The little a means it's for the acid, and the B means it's for the base. Now, the most important part is A over B. That's the mole ratio, and you get it from the balanced chemical equation. The trick is to follow these 4 simple steps every single time. First, write out that balanced equation. Super important. Second, pull the mole ratio straight from that equation. See how it's 1 mole of acid for every 2 moles of base? That means our ratio, A over B, is 1 over 2. Third, you just plug in all the numbers the question gave you. And finally, step 4, you just solve for the one thing you don't know. In this case, Ma. And when you run the numbers, boom, you get 0.10 moles per decimeter cubed. See, when you have a process to follow, even a tough-looking question becomes totally manageable. That's how you lock in those marks. Okay, knowing the steps is one thing, But just as important is knowing how to avoid the common mistakes that cost students easy marks. So let me give you some insider advice on the traps that I see people fall into all the time.
Let's run through these because they are critical. The number one mistake, by far, is forgetting the mole ratio. Students just assume it's 1-to-1, but with something like sulfuric acid, it's 1-to-2. Big mistake. Number 2, just accidentally mixing up your acid and base numbers. It happens. Number 3, not knowing your indicators. You have to know that phenolphthalein is pink in an alkali. And finally, using inconsistent units. Your volumes have to both be in centimeters cubed or both in dm cubed. Don't let these silly mistakes rob you of points.
So, we've gone through the core idea, we've seen it in the real world, and we've walked through the calculation strategy. Now comes the most important part. It's your turn to actually put this into practice and make it stick. So if you take away just one thing today, let it be this simple strategy. First, really get that the core of it all is just H plus OH minus. Second, burn that titration formula into your brain. And third, always, and I mean always, double-check that mole ratio. After everything we've covered, you've got the tools, you've got the knowledge, you've got the strategy. So the only question left is, are you ready to tackle any neutralization problem that comes your way?
I think you are.
All right, that's enough theory. Now it's time for action. Scan this code again, get over to MCQ SPM, and just start hammering out those past year questions. Seriously, that is the single fastest way to make all this information second nature and truly master this topic. Good luck and happy studying.